Hello, my name is Neelaga Rupathyana and I will introduce about the DFvote system. So the DFvote system is a blockchain-based federated learning system for voting system. So in voting systems, there are many types of ways that people can vote in these present times, and in many countries, the voting systems have been upgraded to electronic systems, and even some of the countries rarely use blockchain as well. So basically, blockchain is an immutable ledger which contains some features which really gives all the security and all the transparency that the general public need to ensure the validity of their vote. So that's the reason that mainly that blockchain has been used all over the world. But in Sri Lanka and some countries still it's in paper-based methods, and it's not it's like a innovation here. But the issue at hand is not that. We have the main issue at hand is in many countries like the US or in developed countries, people use the election parties use the data of the voters to predict or to analyze or any analysis done by the voters' data to enhance their political campaigns. So that means using the data of the private data of voters to do predictions or any machine learning trained machine learning models using the private data. So the main issue at hand is using of the data of private data of the voters without the approval of them. So it's going to be an issue for the general public to do it. So that's to overcome that issue. There's another alternative called federated learning. In federated learning, what it does is it it creates an opportunity for the analysis done by the election party. So they will be they will be more considerate about the privacy of the voters. So federated learning was introduced by Google. So what they do is initially there's a global model, and then the global model is sent to different stations. So in this case, it could be election stations. So when it comes to federated learning, it does not expose the private data direct. So what it does is it sends the initial global model to the appropriate stations, and then it trains there, and then it passes the model parameters, which means after you train the model with the data, certain weights and biases are created, and after those weights and biases are created, they are sent to the global server and they are aggregated, and then the that's how the machine learning models are combined. So in that way, you don't necessarily have to send the raw voters data, which definitely exposes their privacy. So you can just train the model in the election station, and send the model parameters, and then aggregate them and create good machine learning models for any analysis or any predictions done. So that's why federated learning is an important innovation. The use of blockchain comes into hand when it comes to the transparency and the security of the model parameters share. So when it comes to attackers or anything, when model parameters are shared, it could when it compromises the security of them, the accuracy and the prediction analysis done by the machine learning model could really reduce. So for that, for the security of the model and for the transparency of the model parameters, to ensure the accuracy, we could introduce blockchain for it. So blockchain is a major innovative solution that comes in handy in different situations. So here, blockchain is going to be really helpful to sharing the model parameters of when federated learning occurs, and then it ensures the transparency and all the security that it can provide the machine learning model, so it can prevent from doing false predictions, which at the end, the main goal of the system is to ensure the privacy of the voter's data. And at the same time, when you ensure the privacy, you could ensure the accuracy and increase accuracy, and you could uh, prevent it from the vulnerability of attacks to the machine learning model. And finally, you can both the election parties can benefit from this, and both the general public as well, because their privacy is preserved. And when it comes to the analysis or predictions done by election parties, still they're gonna get their election voting analysis without compromising the data, the private data of the voters, and then still at the same time they won't violate their machine learning models accuracy as well. So for this, we have created the model for this. So to mimic the federated learning process, I created some functions to create some data related to the voters' data, and then we train the model at different stations, and then after that, aggregating the model parameters. And what it does is it takes the basically dummy data and trains, and then take the model weights and biases and aggregate them, and then after that, it do it, and then it directly does not go to the blockchain, because when it comes to blockchain where and data, when the size of the data increases, the gas fee or a fee that's been given to the blockchain or to miners increases. That means for every transaction that you do, there's a certain fee that you should pay. When it comes to data, when the size of the models or when the size of the model base increases, uh, the price or the gas fee could increase too. So to tackle that issue, we have introduced the innovative solution of IPFS. So IPFS is this decentralized immutable ledger as well. So there you could uh, there's a there's you could store files. So if you have to view the files, there's a hash generated by it. So only the authorized people can look into it. So we have used the Pinata IPFS service to pin the files, which means first after the federated learning system runs, then the model parameters are weights and biases are sent as a JSON to Pinata and pinned it. Then you could get the data from Pinata, and all the election admins can do their security and all this in here. So that's that's the main part which contains the ensuring of the security and both ensuring the price is reduced as well. So here to show this, we have created an Gana account and then created and then we could in the system. So it, this basically means yeah, account of the admin. So at the first you could see that it's successfully connected to the admin account. So with the password and with the wallet, we have used MetaMask wallet to connect to this, and then only the admin can come into this account and log in. So after logging into the MetaMask wallet, what the admin should do is enter the training data and start the training process. So in this code, basically, if you click this button, what happens is it enters the dummy data that I've shown before, and then it, it does the model, trains the model, and then replicates the model and send the relevant weights and biases to the Pinata IPFS. So here, if I click this, you can see that it has trained and for several epochs, and then it has been saved, and it has been saved to the blockchain as well. So if you consider here in Ganache, you could see there are several blocks that have been mined, and it has 12 blocks at the moment. And if you start training again, I can show you again trains, and then the weights and biases are sent to the IPFS as well. And here you can see there are several IPFS, uh, several files that are into IPFS. You, if you can go to the Pinata account, you could view it. So here it has created the models, and you could see the model parameters. You could view the model parameters after going to this. Simple. So that's how you do it. So in here also another block has been created. So that's the main functionality, or the main core functionality of the system is to ensure the privacy by letting only the admin connect to this wallet, and then start the federated learning process and the training the model and the aggregating the parameters and sending them to IPFS. And then you could leave it here. You could go to the go to the IPFS gateway, Pinata gateway, and take the data, the model parameters here for to ensure the security and the transparency of the system. So that's the main goal of the issue that the main goal of this system is to provide the solution to ensure the privacy of the voters' data when it comes to election parties coming to machine learning models using their data. So using blockchain and federated learning, we can both ensure the privacy and both the accuracy of the model as well. So in conclusion, that's the main functionality here. So we used blockchain and federated learning accordingly to tackle one of the major concerns that have been in countries uh, which have been using this voting analysis and prediction to enhance their political campaigns. So I hope this would be a great innovation and a great solution for the issues that have been facing by the election parties and the general public.